root, and if I forget to put the 4, technically it's wrong. So, let me just put that there. So, I was wrapping that one up. This one, I'm going to, same thing, I'm going to break this down. 25 times 10 is 250. 25 is 5 times 5. 10, 2 times 5. And remember, look at the index, right? The index is letting me know that I need 3. 3 of the same factor in order to remove one of those factors. Remove it as 1 from the radical, the square root symbol, or root symbol, I should say. Anyhow, what I have here is 3 5s, 1, 2, 3. Notice how I'm crossing them out, by the way. It's just to remind me what I've already used up. So if all those 5s come out, if I have 3 5s, since I need a third root, I can take a 5 out. Remember, whatever comes out will get multiplied by whatever's out there. So for this 5 will get multiplied by -4 to get -20, and all I have left in there is a 2. So -20 square roots of 2 for that one, and 6 square roots of 180. I guess I could have just broken that down. Here, do that. 18 times 10. And 18 is 2 times 9, and 10 is 2 times 5, and 9 is 3 times 3, and now I have all prime numbers at the end of my branches. And remember, if there's no root here, it basically is a second root, a square root. So I need 2 of each factor to pull one out, so I have 2 2s, so a 2 would come out, and I have 2 3s, so a 3 would come out. Then I only have 1 5, so that'll go back under the radical symbol. And anything that came out gets multiplied. 2 times 3 is 6. Times 6, that was already there. 36. Square roots of 5. That's that. Okay, guys, just going to do these last couple. Remember, you break these down using factor trees. I'm looking for a third root here, so I'm just going to use 4 times 12. Doesn't use whatever you want. 6 times 8. 3 times 16. Either way, 12 is 3 times 4, and 4 is 2 times 2. This 4 is also going to be 2 times 2. So remember, a third root means I'm looking for 3 of the same factors. So if I can take 3 2s, I can pull 1 out. I'm just going to put it down here. And then all I have left is a 3 and a 2. Those are going to have to go back under the third root. So 2 will get multiplied by the -6 that was already there. And again, the third root of under the 3 and the 2 go back in. They get multiplied. 2 times -6 is -12. -12 times the third root of 6. This one is the fifth root, so I'm looking for 5 of the same factor, right? 6 times 16, right? Yeah, that'll work. 6 is 2 times 3. 16 is 4 times 4, which is 2 times 2. Twice, and I do have 5 2s here. 1 2 3 4 5 2s, meaning I can pull a 2 out, right? It'll get multiplied by the 2 that was already there, and I'll still have the fifth root of 3 left over inside the root. 2 times 2 is 4, so 4 fifth roots of 3. And this one is just square root, right? It doesn't have an index here, which is an implied 2. Remember that? So 125 is 5 times 25, which is 5. 25 is 5 times 5. So it looks like I can pull out the square root of 25, right? I can pull out 1 5, and it'll get multiplied by that 6 that's out there. 5 times 6 is 30, and back under the radical is that 5. 30 square